Let's dive right in.
Look at the question.
Sure. So let me just give me like a few moments maybe to read the question, and then I'll let you know if I have any questions.
Mm-hmm.
Okay. So I guess I just have a first question. So it says that we should check if it's within a certain error percentage, which is 0.001. Is that correct?
Yeah.
Okay. So am I going to be allowed to use the root function to check that it's within that error range in the end, or?
No, you are not allowed to use the root function, but you can check it directly. Like, so your function will make sure the error will be within some range, like within 0 point.
But how do I compare it? Like, what do I compare it against? I compare my answer against what? So y is the actual answer, and do I have the answer?
So after you figure out the algorithm,
right,
you can try to prove that your answer can be within this error range.
Oh, I see.
Yeah.
Okay. Okay. So I guess as a basic thing, when we think about nth roots or roots in general, if you look at numbers, for example, 9 is the square of 3. That means it can be split into 2 parts, right?
Mm-hmm.
If you look at maybe something like, I don't know, maybe...
maybe 7?
7, for example.
Yeah.
So 7, for example, it cannot be split into 2 even parts because it's not a perfect square. However, it can be split into two parts that somehow, when we multiply them together, it becomes 7. So there's this value y times y that gives 7. So the trick is that we need somehow to, if n is 3, we need somehow to split this into 3 parts. So it's y times y times y.
Good thinking.
Yeah. So basically, what we need to do is we need to split it into these 3 parts that, when multiplied together, they give you 7. So if we, so the operations that I'm thinking about, for example, for 9, it seems easy that you could just start, since n is equal to 2 in this case, n is equal to 2, then it seems easy that if I just do 9 over 2, it's going to give you 3.
It's gonna be 4.5, right?
Oh, right, yeah, it's going to be 4. Okay, my bad. But since it's integer division, so it's gonna be 4. Right? So, so I guess what we could do is, now since we have this 4, we can try multiplying 4 times 4 and checking. 4 times 4 gives us 16, so we're way off, because the answer is supposed to be 9.
Yeah.
So we try to divide again. 4 divided by 2, it gives us 2. So now we do 2 times 2. It gives us 4. And now we see that we're below our range. So we try incrementing this maybe by 1. So we become like 3. And now that that works. But I don't know if this is feasible, for example, for the 7. Because for the 7, if you divide it by 3, it's 7 over 3 is about 2, I think. And 2 cubed is 8. So you know that you need to reduce your answer a little. However, you can't try 1 because 1 is too narrow. So maybe...
So you are basically searching for a number between 0 and the number you want to find the root of.
Right.
Yeah. So how do you usually search for
something? Usually the most optimum way is using binary search. But since here we're doing like we're dealing with decimals. So I
think you can also use binary search for this question.
You think I could use binary search?
Yeah, definitely.
So for example, start in the middle, 7 over 2 is equal to 3.
Yeah, so the lower bound for the first will be 0 and 7.
Right.
Yeah.
So, but then how do I know, how do I get this 1.9.13? Because it's these decimal places, I don't know how they arrived at.
So I think when you divide it by 2 for many times, then you will get a decimal number.
Oh, so you're saying I shouldn't do integer division?
Yes, it shouldn't be integer all the time. Right?
Yeah. Okay. So maybe let's do this 3.5 times 3.5, and I don't know. It's the result of this. By the way, we're supposed to split it 3 times. So let's try 3.5 again. So now the result of this is unknown because 3.5 and this is like 42 or something like that. So this is way off. So we know that we need to the number we're looking for is between 0 and 3.5. So we start looking within that range. So now we divide 0 plus 3.5 over 2. And that value is 1.75, I think. And now we try 1.75 times 1.75 times 1.75, on which I have no clue to what is the answer. But
I think you're on the right side.
Yeah, I think it's it's like in between. Like what I'm doing is correct. I think the binary search approach is correct. Just basically splitting till you're like within a certain error range, and then you can like check if you check, for example. So the number you get out here, let's call this ans. You take this answer minus your number, which was x, and you see if this answer is within 0.01. This is your base case that stops you. Otherwise, you keep on continuing. If the number after multiplying all this gave me the number I was started off with initially, that means that I found my root. So I can basically use this to tell me when to stop. Okay, so I think I'm gonna start coding. Do you think I'm in a good position to start coding?
Sure.
Okay. Okay, we're only dealing with, do I need to check for negative numbers? Or should I assume that everything is going to be positive?
I think the assumption is you will be given a positive number.
Positive numbers? Okay.
Yeah, both of them are positive.
So I don't need to check for negative ones?
Yeah.
Okay, cool. So I'm going to start with a double. And
actually, it's gonna be non-negative, so
okay.
probably it's gonna be 0.
Okay, that's okay. Okay, and then I have a double end, and this is equal to x. And then I have a while condition, and basically this is going to be, oh, 1 second, so I also have another double, which is our error, which we are just going to hard code for now to 0.01. Okay, and while okay, so we need another value here.
Mm-hmm.
Okay. I think I need to do at least the first calculation, or I could do like a do while or something. Do while result minus. No. Can I use the absolute function?
You can.
Result minus x is smaller than the error code. Okay, and then basically what we're going to do here is that we're going to do double mid is equal to start.
I just want to mention like the answer should be greater or equal to.
Yeah, but this is my while condition, so I'm gonna loop until this condition is. Oh wait,
what? It should be less than.
Oh, okay.
Should be less than the error. Yeah.
Less than.
Greater or equal or less than.
Oh, okay. Greater than or equal. Okay.
Yeah.
Yeah. Okay. Thank you. Okay, so double start and then divide by 2. And then we need something. Okay. I'm gonna create a function here called multiply. Multiply, double multiply.
Oh, actually, you can use a power function.
Oh, I'm allowed to use that? Okay.
Yeah.
Oh, okay, cool. Now that simplifies a lot. Okay, so now you can take math.pow, and then your base is mid, and then n, and then this returns a double, so we're just going to attach it to result. And if result is greater than, if it's greater than the x, then what we are going to do is set, if it's greater than, then we need to set our end is equal to mid, else if start is, or my bad, result is smaller than x, then our start is equal to mid, and then that's it. And then if it's equal to x, we're going to find this here. So this will keep it going if it's equal to x. So maybe we should have something here that lets it break. Oh, I forgot a semicolon here.
Yeah, I have a question. Why do you have to before while?
Oh, because the initialization of result is not done except here. Do you see? So I didn't want to write the same exact code outside here. So that's why I did it to do it at least one time. And then while this continues.
Okay.
Okay. Yeah, I think this is good. I just need to trace an example so I can make sure that my code is working correctly. So perhaps let me maybe use an easy example first. Let's do an example like 9. So x is equal to 9 and n is equal to 2. And the answer we're looking for is supposed to be 3. So let's see if we get that. So we have our start here. Our start is equal to 0, and then our end is equal to 9. So start plus end, 3.5, because we're not doing integer division because these are doubles. So double over integer gives you double. Just to be safe, we can do times 2 divided by 2.0. And then this gives us here, initially this gives us 9 over 2, that's 4.5. And then 4.5 squared, that's, let me see, 4.5 squared, that's 20.25. 20.25. So now x, which is 9, the result is greater than, so end is equal to, so now our end that was 9 now is going to be replaced to become, what was it? 4.5. Okay, and then we continue. Math, a result minus x. Obviously, result is 20.25 minus x minus 9. It's way greater than or equal to the error. So we keep on looping. We go in here again. We divide start plus end. So 4.5 over 2. That's about 2.25. And then what else do we get here? 2.25 squared. It's going to be 5, give or take. 5 something. And then 5 is smaller than, so start is equal to the mid, which was 2.25. So now our start is 2.25. So now we're within this range, so we're getting closer. So it seems like we're almost there. So this value divided by 2 is going to be 3.375. And then when we square that, that's almost going to be 9, but not really. 375, and then squaring that becomes 11, right? 11 something. 11.39. And then And so this is greater than, so our end becomes our mid. So our mid was 3.7375.
I think you're good to run the test.
Run, okay.
Run code and check if there's any compiler.
Right. Okay, cool. Yeah, I think we're good. Okay, let me write a system. Yeah, I think this works. Let me just do root of 9, comma 2, and let me see what it prints out. Oh, I think, okay, so I got the answer, but we got, yeah, so this is a part of the problem. So what we need to print is mid, actually, not, so this guy, and then this guy. But, oh, wait 1 second. So mid is actually not defined outside the scope, so let me perhaps take it out. Maybe even set it, maybe. Is there any case that I wouldn't find a solution?
So it may be x equals to 0.
X is equal to...
n equals 0. And it's gonna be positive, so don't worry about it.
Yeah.
So x might be 0, and
if x is 0, then
mid will be 0.
Okay, mid will be 0. Okay.
So how about this edge case?
Yeah, if mid is equal to, if x is equal to 0, so now you have 0 to the power of whatever it is. 0 to the power of anything is going to be 0, right? So
it's gonna be
it's going to return 0.
Yeah, it's returning.
Yeah, okay, it's running correct. Okay, let me run this now and see what we get. We should get 3. Something close to 3. Yeah. So now I got 3. So I think the solution works, and then it runs in O of log n because we're doing binary search. Obviously, the runtime and the runtime of this power function is so. I don't know how exactly it's implemented, but if I was going to do it the naive way, just by multiplying it a bunch of times, so actually the runtime would be n log n, because you're doing this binary search log n times, and each time you're doing n calculations on the number. However, I think that there's an efficient implementation for the power function. I just don't know how fast it runs.
The power function takes constant time.
Constant time? Okay. So then we just have a logarithmic solution, log n, because we're just doing binary search on the number.
Yeah, great. But if you do it, like create another function to calculate the power, it's gonna be, you said n to n?
N log n.
N log n.
Yeah, because you have this function that takes n time. Oh, by the way, so n log x, this is the correct, n log x. X is the number, x is the number that we're doing binary search on, so that's why it's log x. This is and then n is the number on the square root number. So let's say in our example, 9 and 2. So you do this this multiplication, you do it twice each time. However, you do this twice operation only log 9 times because you're doing binary search on this 9. Does that sound correct?
Okay, yeah, for the root function.
Yeah. Okay, cool. I think we're good to go.
Yeah, you did a very good job.
Thank you.
Okay, let's swap rows. So the problem is smallest substring of all characters. So we should consider the edge case if the input is an empty string.
Right.
Okay, so the example given. So the first input is an array of array of characters.
Yup.
And the second input is
A string. Yup.
And I am going to find a substring that contains all the characters in the array.
Yup. The smallest substring.
Okay, so if I want to give another example.
Yep, go ahead.
Like array is X, Y, so if I want to have all the 3 y's in a substring, then the smallest would be x, y, y, z, y. So the output might be would it be the solution? Would it be the output?
If it's X, Y, triple Y, Z. Yup.
So it's 5 characters. Do they have to be sequenced?
No. Because, like, based on the example given, it was XYZ, so the output was ZYX, so it doesn't have to be in order.
Okay, yeah. ZYX. So I think for this question,
let me know if you need any hints, because I'm not really good at giving hints at all.
Sure. Okay, let me think about it first.
Yeah, take your time. Take your time.
Okay, one brute force solution might be, so I'll take the first element of array and try to find it in a string.
Okay.
And if I find it in a string, I'll take the second element.
Take the second one, okay. And then?
And find it in a string.
Okay. Let's suppose you found all of them. What do you do with what you found?
So, firstly, I might find all of them, the first appearance of each of the character, like X, Y, and Z. So in this case, the answer is not the shortest. So it's gonna be X, Y, Y, Z.
Mm-hmm.
But I need to find the shortest. Okay, I think I'll find the shortest substring of the first two,
Okay.
and then try to add the third one.
Okay.
So is that gonna be an optimal solution?
So you're saying is, give me an example, maybe so I can understand better. So you're saying use X, Y, and then try to find like the smallest substring that contains X, Y,
Yes.
and then try to look for the smallest substring that then contains X, Y, Z.
Yes.
Okay. Yeah. So what would the runtime of that solution be?
So it's gonna be fine. I don't think it's gonna be the optimal one.
What is the runtime?
I think it's gonna be exponential.
You were scared to say it. Okay. It is. I don't know. It's not exponential, but it's pretty bad. So I think there's a better brute force solution to start thinking about, and I think what happens if you consider all the possible substrings, because there are only so many of them. What are all the possible substrings? How many of them are there? There are only n squared substrings, right? Because you have to start from the beginning. So it's either xy or xyy or xyz or yz or so that's the start. However, that's definitely not the optimum solution. So having said that, how do you think we can like move from like this brute force solution to something more optimum by instead of considering Like if you notice, if you trace out this brute force solution, you'll notice that there is something off. So.
Okay. I would definitely ignore the substrings that are greater than the number of characters in the array.
Greater than, okay.
Yes. So you mean there are n square subsets of the string?
There are what?
There are n square subsets.
Yeah, n squared, yep.
So the subsets could be the entire string or like zy and zy.
Yeah, basically, starting from x, it could be either x alone, or xy, or xyy. But notice. This is the part I want you to take notice of. So if we start with x and then we go to xy, we already know what x is. So there's a repeated computation here, and then you go to xyy, and then from x to xyy z. And then from xyy to xyy zy. And you keep on continuing like that. So this is the brute force solution. So my question to you is, how can we move from that brute force solution to something more optimal? First of all, do you understand what I'm trying to explain?
Yeah. I understand the brute force solution.
And you said we can ignore the substrings that are greater than the length of the string. Well, that will not necessarily work because
it's probably greater than.
Yeah, it might be greater than. So in this example, it was exactly equal to, but it might be greater than. Perhaps you can ignore the ones that are smaller than, obviously.
Yeah.
But I mean, there's either way. There's a better solution that we can achieve.
So if we go from xy,
right?
We check xy, and it's not gonna be the
shortest yet.
Solution. So we check xy.
Right?
And we check xyz.
Exactly.
And it's probably gonna be the solution.
XYYZ. So right now currently this is our best solution. It's the length that's 4. So if we keep on continuing like that, we should eventually we'll realize that there's this ZYX that's the best one, but that's after almost in the end after the n squared computations. So how can we improve from there?
Okay. So XY.
Maybe perhaps we can look at a better a slightly smaller example, because maybe this is pretty big. So maybe if you look at this, and let's do maybe a string that's x a y z. Yeah, that's it. Let's just do something like that. So if you trace out, it's not too long to trace out. So
it's 10 o'clock.
You can see that we're starting out with x, and then to xa.
And then xay.
And then xyz, and then now we have found something that contains all our characters. But then we need to also check starting from y. Yup, exactly. And then moving from there. The thing to notice is that we're doing this repeated computation, because from x, once you're at x, you know that when you have your 2 pointers, if you're standing, let's say we're just standing with a pointer here that's like this, and we have a pointer that's here that's like this. So you know that here you already have one x. You should be able to know that. And then when you move here, you already know that you already had one x. You wouldn't need to worry about that x. You would just need to worry about that new character that's an a. So you say, oh, I have an a. So now I know that, like, somehow I know that I have xa. And then when I move here, I know that I had an xa and I also had a y. So I wouldn't need to worry about recalculating that, checking if all the string contains the characters. I would just need to worry about the new character that I have. So perhaps maybe that's a good way or a good place to start. I would like you to maybe perhaps give you like a couple of extra minutes to think a little about this approach. And if you can't arrive to a solution, I would like to see at least the brute force solution that we talked about. I think that I just want to see some code from you.
Okay. So if in this example, I'll start from x.
Right.
And I remember the index of the first x.
Right, exactly.
And I remember the index of the first y.
Right, exactly.
And I ignore the.
You can basically as you're going know what's the count of these characters. So for here, for example, you know, as currently our pointers are standing, we know that we have this 1 and 0 and 1y and and 0 z.
Yeah.
So we know that. So once we move our pointer, we can like know that once we move here, we know, oh, currently I have an extra z. So now I found all my characters, so that must be the current shortest substring. So I can see if that is the shortest substring. And then I move this guy here, and then I basically do the exact same checks again.
Okay. So I'll start from the string. And I need an array to check if I have met the captor.
Yep.
So it should be. How do I get the length of the string? I think
there's a method called dot length, as you said. It just takes parentheses. It's a method, not an attribute.
String dot length. Could you give an example of how to get the first character in the string?
Right. So to get a first character in a string, there's a char app method.
Oh, okay. So it will return a character?
Yep. It will return a character.
Character is string dot.
Yep.
Okay. I'll check if this character I get is one of the characters in the array.
Okay.
So I will loop the array again. Oh yeah. And track. So how do I gonna check if I have met all the characters in the array?
Well, you could do like a traversal on the array again to check that all the array contains values greater than or equal to 0, greater than 0. Sorry. However, I would like you to like maybe perhaps because we're closing in on time a little, so maybe give you a little feedback as you're going through. What was the reason behind your choice of an array as a data structure for counting? Because I think the choice of an array limits you in certain things. For example, the question you just had: how can I check if I have met all the characters? So if you used other data structures, I think another data structure other than an array, I think it would give you a better idea as to what kind of characters you have, and perhaps using some of the functionalities of that data structure. And mainly the data structure that do you have any data structures you're thinking of that could be better for this job?
Because the array length is gonna be less than 30.
Exactly. So the array length is always going to be the 3, for example, in this case, because we already have allocated 3. So what data structure are you thinking of? Do you have any data structure in mind?
Probably using bit manipulation.
Bit manipulation? You could. I think you could, but I think a better data structure would be like perhaps like a hash, for example. And the reason is you could just check the size of the hash. Because once the value decreases than 0, you could just get rid of that element in your hash.
Yeah.
So, yeah, that's... Okay, continue from there. I mean, you can just continue on the... I don't want you to keep on... just continue on the array. Continue on what you have. We will work with that.
Okay. So I have a question. So if we use a hash,
right?
How do we know all the elements have appeared in the string?
So basically, like let me show you. For example, when I had this, my hash would not even include the z. My hash would only be x, y, and they map to 1 and 1. So when I do the size, I know that if it's equal to the length of the string, that means that I have met all the characters. And my hash will always include only the elements that I've seen in the array.
But if you have A,
I wouldn't include A in my hash. I would skip it. Like, let's say, for example, I met my A, right? So I'm here, and I met my A. Let me bring back the pointer. So right now, Y is 0, right? Y is 0. So, but in my hash only includes X at this point. Like, maybe let me show you how the hash would look like. It would include X, and then this X points to 1. That's it. So when I do dot size on this hash, it returns what? It returns 1. And I know that if I do dot length on this guy is equal to 3. So 1 is smaller than 3, so I haven't met all my elements.
Yeah. So when you meet A,
right. So when I meet A at this point, I check is A. So you can do something like this. You could have something like this. If you could have another initial hash instead of using this array, you could have another hash that contains something like this, hash 1, and this is hash 2. And then hash 1 contains all the elements. For example, X contains X, Y, Z, and it's like a hash set. So you just do if your hash 1 contains A, then you include it in hash 2. If it doesn't, then you don't include it.
So basically, I just
throw in everything here into a hash. Yes, that is.
Transform array.
Yeah, because the hash allows all of one access, so it's easy to just check if it contains this value or not. Yeah, I think this is.
Yeah, I think it's a better.
Yeah.
Yeah. So.
You could even get away with just using one hash. I think that would be fine. Just having the hash 2, and then basically you could just have another variable that gives you like the count of unique characters that you have seen so far, and you can get the count of unique characters by checking if the current count of this guy is new. That means you're adding a unique character. So for example, let's see if let's assume that we had a hash that looks like this.
Okay.
X, Y, Z. Right? So, and maybe let's get rid of this guy. And right. So when I get when I'm starting from the beginning here, when I get the count of X, it's 0, right? So if it's 0, that means it's the first time that I'm seeing it in my current substring. So then I increment my count to become 1. Correct?
Mm-hmm.
So
if you read A, but it's not in the hash.
Exactly. So I won't include it, and I won't increment my count.
Okay. I have another question. Like when you find the first possible substring,
right?
What do you do next?
What you do next is you basically increment your what's it called? Your head counter. You increment this guy.
Okay, then.
And then you continue on doing the same thing. Increment this guy, continue on doing the same thing. And then this guy, and now consider this substring. Y, YZ.
Mm-hmm. So are we going to implementing codes?
I think we what we discussed.
Yeah, we are running out of time.
Yeah, we are running a little out of time. I don't know. I think it would be good to see a little bit more of code.
Okay.
So perhaps, but I also think we discussed kind of like what is the approach, and I saw like your thought process. I would just like to give you some feedback about like in general about things you've done that I think are pretty positive. I really like the idea that you didn't jump into your code straight ahead, and we kind of were discussing this is a cooperation between both of us. So it really helps me as an interviewer and you as a candidate if we are able to discuss the solutions with one another, because in the end, the person who's trying to hire you, he's trying to hire you as someone to work with them on the team, so they need to see that collaboration, you know? So I really like that. And plus, I wasn't sitting here bored at all because I felt like I was with you in the problem, so that's great. And also I like that you started out tracing your example, using your own examples. I think that was pretty positive. That's pretty good. What I would like to see is I would like to see more understanding of fundamentals of data structures. So for example, the concept of using a hash is very important when it comes to string questions, because a lot of times you need to keep that fast O of 1 memory access constant time. So that's crucial. This problem is not easy. This problem was asked mainly in interviews by Google. So this is a pretty hard question. But overall, I think you did a good job, and I think you I think I would have liked to see more code, but I think overall pretty solid.
Thank you very much.
Yeah, your communication is pretty good. I would just say.
You're very supportive reviewer.
Yeah, I think you should just keep on continue practicing, continue using Pramp. It's a great resource, and hopefully within seeing these couple questions, you'll get better understanding of your data structures, better understanding of how to solve these complicated string problems. But yeah, good job.